Here we have a SAT math problem. Okay, let's go to the question. In the figure above, if the volume of the cube is 64, what is the length of diagonal PQ? Okay, in the given cube, we have to find the length of the diagonal. That is, we have to find the length of the line segment which connects the 2 points of P and Q. And also, let me name this vertex as R. And also, let me draw the edge of the cube, that is PR over here. It's given in dotted line. Let me make it as a solid line. And also, let me draw the diagonal of the base of the square. Since it's a cube, each face has to be a square. I've drawn the diagonal RQ of the base. Since it is a cube and each face is a square, the diagonal I've drawn for the square base will divide the square base into two congruent isosceles triangle. Particularly, each isosceles triangle will be a 45, 45, 90 special right triangle. That is, here it will be 45 degrees and here it will be 45 degrees, and it's we'll have a right angle over here. So here we get as 45, 45, 90 special right triangle. And since we have square at the base, we can assume the length of each side as A. Here it's A, here it's A. So since it's a 45, 45, 90 triangle over here, then the length of the hypotenuse has to be A times the square root of 2. And we know that the length of PR is also A because it's a cube and the length of each edge has to be same. Okay, now let's consider the right triangle PRQ over here. In this right triangle PRQ, we know that the length of this PR, this leg is A, and this leg RQ is A times square root of 2. Our aim is to find the length of the hypotenuse PQ, which represents the diagonal of the cube. Okay, now we can use Pythagorean theorem in this right triangle PRQ. Let me write this stuff over here. Now let me consider the right triangle PRQ. According to the Pythagorean theorem, we have PR square positive RQ square equals to PQ square. Okay, so for PR, we know that it's A square positive. For RQ, we know that A times square root of 2, the whole square. PQ, we do not know the length of PQ, that's what we have to find. We can keep this one as it is. Okay, anyway, so if I want to get the value of PQ, I must be knowing the value of A. So how do I have to get the value of A? For that, we can use this particular piece of information. That is, the volume of the cube is 64. Okay, so here the volume of the cube 64. So when the length of each edge of the cube is A, then the formula to get the volume of the cube is A to the third power. That is, the length of each edge has to be raised to the power of 3. So this is the formula to get volume of the cube because we have assumed A as the length of each edge equals to 64. Okay, A cube, and let me write 64 as 4 to the third power because 4 to the third power equals to 64. Okay, my aim is to solve for A in this equation. Here, two terms are equal with the same exponent. Whenever two terms are equal with the same exponent, we can equate the bases. So when I equate the bases, I'm getting A equals to 4. Okay, now I got the value of A, that is 4. Now we can plug in A equals to 4 over here. Then I'm getting 4 square positive 4 times square root of 2 the whole square equals to PQ the whole square. Then we get 16 positive and 4 square times square root of 2 the whole square equals to PQ whole square. Let me write it. And 16 positive 4 square is 16. This 4 square is equal to 16. The square root and square root cancel. I'm just getting 2 equals to PQ the whole square, and 16 positive 16 times 2 is 32 equals to PQ the whole square. Okay, so when I add 16 and 32, I'm getting 48 equals to PQ the whole square. Okay, now to get the length of PQ, I have to get up this square. So for that, we have to take square root on both sides. Let me take square root on both sides. Square root and square root cancel out. Then I'm getting square root of 48 on the left side. But before that, we can decompose 48 into its prime factors. So it's a prime number. Let me divide it by 2. Then we get 24. Again, I divide it by 2 because it's an even number. I get 12. Again, I divide it by 2. I'm getting 6. Again, I'm getting divided by 2. I'm getting 3. So this 48 can be written as 2 times 2 times 2 times 2 times 3 equals, on the right side we just have PQ. For every two same numbers multiplied inside the square root, one number can be taken out. For these 2 to 1, 2 can be taken out, and for these 2 to 1, 2 can be taken out. Then we get 2 times 2 times. Still we have 3 inside the square root, so it's square root of 3 equals to PQ. 2 times 2 is 4. 4 times square root of 3 equals to PQ. Okay, now I got the length of the diagonal PQ, that is 4 times square root of 3. We find 4 times square root of 3 in the answer choice C. The correct answer choice for this question is C.